Good morning, students and viewers. We shall be discussing about coordinate geometry as a topic, and we are going to consider gradient of a line. So the gradient here is the gradient of a line. So in our second video, we shall be considering equations of straight lines. Now we begin with because students are familiar with trigonometrical ratios, it is better in this sense to talk about the coordinate geometry in terms of one of the trigonometrical ratios. Students are familiar with the Cartesian coordinate, and the Cartesian coordinate simply here is y, and this is the x-axis. So we have the y-axis and the x-axis. Given a straight line, line AB is a line segment. Every straight line is known that can be infinitely extended. So this is just a line segment. So by line segment, we write AB to mean line AB, or we write AB to show a line segment AB. Therefore, at this point, we have here is a point x1, the value of x. Here is a point x2. Here is a point x1. Here is another point y2. Sorry, here is y1 because we are on the y-axis. Here is x1, x2 because we are on the x-axis. Therefore, students can see that we can plot a dotted line parallel to x-axis, and we can draw another straight line parallel to y-axis, and here is now a right angle. Completely, we can call this, let's mark this place C. ABC is now a triangle, a right-angled triangle. Suppose here is an angle called theta. Students will see that from here to here is x2 minus x1, because from here to here is x1. So from here to x2, the distance here to here will be x2 minus this distance, which is x1. Therefore, we write x2 minus x1 to the line AC. So we simply write AC is equals to x2 minus x1. Going to the opposite side of the triangle, so here is y1. From here, from 0 up to this place is y1, up to this point is y2. So if we want to get the exact value of this height, this line ABC, we say y2 minus y1. Here is y2 minus y1. Therefore, line BC is equals to y2 minus y1. One will see that the tangent to this angle theta is written as tan theta is equals to opposite over hypotenuse. Where is the opposite? Line BC. So this is BC over adjacent. Sorry, opposite over adjacent, not hypotenuse. Therefore, we say over line AC, line BC over line AC, which is equals to BC is y2 minus y1 over x2 minus x1, which is AC. So this defines a tangent At this point, we define a tangent. So a tangent, the gradient of a line simply means the tangent which the line makes with the positive x-axis. You see, this line AB makes a positive angle with the positive x-axis. So the tangent to an angle which a line makes with the positive x-axis is known as the gradient or the slope of the line. Usually, we write m to be equal to the slope. Call it slope, or we call it gradient, which is equals to increase in y over increase in x. Students that took lectures in Math 105 are familiar with this concept, and this is what we call the gradient of a line. This is line AB. So this point is marked x1, y1. Here is marked x2, y2. So it's a pair. Wherever you see a line is denoted by 2 points on a Cartesian coordinate system, or a pair. It's always a pair in terms of x and y. One can easily see an example. We may be asked to find the gradient of a line joining these points A, which is -1, 2, and B. The line is joining 2 points on the Cartesian coordinate system, A and B, -1, 2, 3, and 4. Simply means to solve this, one will say one can even draw the Cartesian coordinate system and have a picture of the line we are going to make calculation on. So the line is, let's say, 1, 2, -1, and then 3, 4. X, 1, 2, and then 3, or maybe 4. The point A1, the point A, x is -1. Somewhere here, x is -1, while y is 2. X is -1, y is 2. So from -1, we move up to 2 and mark. We go to the second coordinate, which is B. The second point, that's x is 3, y is 4. X is 3, while y is 4. So we move up. Where 3 is meeting 4 is this point, so we mark it. So we draw a straight line to join these 2 points. So this is a line segment, so we can increase it because it's a line segment, or you stop from here and just take a line segment. You can increase the line infinitely. The most important thing is to have just a line segment joining these 2 points. So the slope is, or the gradient, which is usually denoted by m, is equals to y2 minus y1 over x2 minus x1. But y2, this is x1, y1, x2, y2. But y2 is 4 minus y1, which is 2, divided by x2 minus x1, which is 3. So minus 1. And this is equals to 4 minus 2 over 3. Minus minus will give us plus. 4 minus 2, the answer is 2. Over 3 plus 1, the answer is 4. 2 can go here, 1. 2 can go here, 2. So we have 1 over 2 as the slope of the line. Thank you for watching.